Let's fit a simple model to the frequency workspace. Tick the factors you want to include in modeling frequency, and then click the Fit GLM button here. The checkboxes mean the predictor is included in the model. Numerical predictors like age and power can be fitted as either a CAT version or CONT, depending on which version that you tick. CAT means treating the bin levels as if it was its own categorical level. CONT means just fit a continuous linear line through the predictor without worrying about binning. Even when you fit the CONT version, they are still binned for display purposes, so we can compare actual versus fitted values in each bin, but the model itself doesn't treat this variable as binned in any way. Let's fit power and vehicle as a straight line, age as categorical, and throw the rest in too. Click the Fit GLM button. Looking at garage type again, we have some more lines appearing on the chart. The blue line shows the beta parameters. These are the pure effects of this predictor, taking into account all other predictors at the same time. The blue line being a pure effect is our model, at least for garage type. The left axis here relates to the blue line. The base level is the one with the highest exposure level, and everything is shown relative to that level. In this case, garage is the base level. It has a beta of 0. Carport seems to have a slightly lower beta at negative 0.0159, indicating that, at least in this data, being parked in a carport is ever so slightly less risky than being parked in a garage. However, being parked on the street or at a train station is more risky. These pure effects are estimated by the model. The model can't know for certain what the true pure effect is, but the beta is an estimate of this pure effect. It can only estimate the beta from the data that you gave it. It provides a point estimate and confidence intervals around that point estimate. Some can be estimated with high certainty and some not. The bars around the blue points are 95% confidence intervals. We are 95% confident that the pure effect beta parameter lies somewhere between the upper and lower bounds of this interval. For instance, for carport, the confidence bands seem to span from around positive 0.14 to negative 0.17. These ranges give some clues as to what variables should be excluded from the model or what levels should be grouped. 0 falls safely within the carport confidence interval, so we might want to group carport and garage into a single level, called garage or carport, say. Similarly, the beta coefficients for street and train station seem to be close together, in fact falling within each other's confidence intervals, so we might want to group them together. The smaller the confidence interval, the more certain we are about the beta estimate, and vice versa. The confidence interval for the dot level is so wide that it seems the dot level could be grouped with either the garage or carport group or the street and train station group. Visually, the midpoint of the range is closer to that of street or train station, so this might seem a more sensible grouping. Note that the number of beta coefficients estimated is 1 less than the number of levels. Each beta is an estimate of how much that level differs from the base group, i.e., how much does carport differ from garage, or how much does street differ from garage. There are 5 levels here, 1, 2, 3, 4, 5. So 4 beta coefficients are calculated. The base group, in this case garage, doesn't get a beta. It's always shown as 0. Grouping levels produces a simpler model, since fewer beta coefficients need to be estimated. If we grouped carport and garage together, and dot, street, and train station together, then the number of levels falls from 5 to 2. The number of betas to be estimated therefore falls from 4 to 1.